Hi, today is March 22nd, 2010, and we have Mr. Charles here and myself, Marco, and we're going to talk about the periodic table in which Mr. Charles called the schemata of the elements.
How you doing, Marco?
Hi.
Well, we're going to talk a little bit why I developed the schemata of the elements. The traditional table, I have one here. There are many different formats, but this is one particular format that's pretty much used today. What you can see is that it's broken up. You have the elements down here at the bottom, so they break up the sequence of the atomic numbers. The periodic table is listed by atomic number from 1 to 120, let's say. And over here, as you get to element 56, on most of the conventional tables today, they jump down to these elements, 57 over to 70, back up to 71. When you get to 88, element 88, they jump down to 89, they go back to 102, and then they jump back up to 103. When I was a youngster and I saw that, it made me wonder why, if the elements are sequential, and you have what's called the Aufbau design, or the progression and atomic number, then why would they put these elements down at the bottom? The reason is it has to do with groups. And here I've colored the table the way generally it's colored, to show the different groups of elements that have similar characteristics and properties. And so these characteristics of these elements, which are down here, the inner transition elements they call them, they place them down at the bottom, because if they were to put these up here in between, the table would be very, very long. It would be way out to here. So one way that they've done this is to put these down at the bottom, but by putting those down at the bottom, you break up what the natural sequence is in the atomic number. To me, ever since I was a youngster, that bothered me. Why? I don't know. It's just that if nature gives us a sequence and then we break the sequence, it just doesn't seem, it's never seemed to me to be acceptable. With that in mind, I started studying the placement of the elements on a table, and I tried to create a table which had a sequence from 1 to 120 without breaking it up or without making a very, very long table. And for example, this is what I call the electronic schemata of the elements. It has to do with the electron count, which is also the traditional table. It's based mainly on the electron count, the periodicity of the electrons, meaning the periods of the different groups of electrons. And I've color-coded these on the schemata which I created. And this schemata, or this schema design, goes from 1 to 120. And here we can see it here. This is the basic table. And it goes from 1 to 120, and there's no breakup. Those elements which were at the bottom are now up here where they're supposed to be, I would say, in the sense that it's sequential. So now you would go from 56 to 57 and 88 to 89, and you wouldn't break anything up. You do have little gaps in between, but it's nothing compared to what the gaps are on the traditional table.